Good morning. Happy fantastic Math Friday to all of you. And welcome to the measurement test walkthrough. I'd encourage you to have out your copy of the measurement test to note down any mistakes that you might have made and to try and understand how you made those mistakes and how you can avoid them next time. Make any notes about your thinking process on your test paper or on a separate sheet of paper that you can use for studying later, and show me those notes for the extra 5% on this test. So the first thing that we have is some tests of how well you're thinking about radicals. These types of numbers here are called radicals, the ones that are like the square root type numbers. And the way we can estimate those is if you know the perfect square that's 25. Well, if you know that 5 squared is 25, then this is just equal to 5. Because this is a set of instructions that says, go find me the number that when multiplied by itself gives you 25, and that number is 5. It's equal to 5. Don't write it up here like that, like 5. It's not a division sign. It's not going to go there. You also don't say that the square root of 25 is equal to 5 squared. This is also incorrect. Okay, that's not what that means. Actually, the square root of 25 is the square root of 5 squared. That would be true. But the other is not true. This is true. So write it that way. And that's what we use this notation for. And then here, the square root of 4,900. Here we can use factor trees to figure this out. I can say 4,900 is equal to 49 times 100. 100 is 10 squared, and 49 is 7 squared. And so there, this would be the square root of 7 squared times 10 squared. I didn't change anything. I just wrote 4,900 in a new way. So that's equal to 7 times 10 squared, which is 70 squared in there. So 70 is the answer. That's what we would square to get that. Another trick would be, I notice that there's 2 zeros here. So that must be 10 times 10. And then this is a perfect square, 49. So I can take that apart and use and know that 7 times 10 would be 70. 70 times 70 would give me 4,900. And you could test that with a calculator, find that it's true. So here there's 4 zeros. So in that case, we know that this, and then 16. Some of you said 800. And I'm afraid 8 times 8 is not 16. 8 times 8 is 64. So that's a classic mistake. So laugh at yourself and find yourself a little bit funny, and then learn from those mistakes. It's good to have a positive attitude about these mistakes and know that I make them too. Okay, so this one will be 4 times 100, or 400. 400 squared will give me 160,000. So that's equal to 400. Okay. Now with these ones, we want to be able to estimate these types of things very quickly without using a calculator. And here's how you would do it. The square root of 63, well, I know that 7 squared is equal to 49. The square root of 63 squared would be 63. And 8 squared is 64. So the square root of 63 is going to be between 7 and 8, and a heck of a lot closer to 8. So this is maybe about 7.9. Maybe it's even bigger than 7.9, like 7.95, something like that. The square root of 88. Well, here I know that 9 squared is 81. The square root of 88 squared would be 88. And then 10 squared is 100. So this looks to be between 9 and 10 and a fair bit closer to 9 than 10. So I'm going to say that this is about 9.4. And then the square root of 441 confused a lot of people, even people that had the other ones correct. They were confused by this for some reason. So if I look at this one, I can see, well, 20 squared is 400. If I check 21 squared, then I'll get 441. So this one is going to be between 20 and 21 and a heck of a lot closer to 21. It's the same thinking process. So I know this is going to be equal to something like 20.95, really close to 21. I'm going to circle the final answers just so that whoever's marking my work can see them very easily. But that would be my thinking process for all of these. If you have a different thinking process for how you guess these types of things, we can chat about that. But I would certainly be thinking, what are the squares that are on either side of that number? My answer is going to be between those two numbers. I don't know a nicer way to think about this than that allows me to solve them quickly. Next was testing your knowledge of the Pythagorean theorem and which one of those expressions could be used to solve some of these problem types here. So in this case, we have the Pythagorean triple 5, 12, 13, and indeed 5 squared plus 12 squared does equal 13 squared, so this is a right angle triangle, and this would be the expression that would best summarize that. This you'll find is just not true. 5 squared minus 12 squared is a large negative number. It does not equal 13 squared. This is true, but has nothing to do with anything. And this is also true and very interesting, but not relative to the Pythagorean theorem, really. So this one is correct. And that's also a hint of the big tool that you're going to be using for the next two questions to answer these two questions here. So if I want to know the length of this side, I need to use the Pythagorean theorem, which is if I label this A, B, and C, then I know that, and this is something you want to do for all these questions, start by writing out your formulas. A squared plus B squared equals C squared. I write this out, and then I notice A is 120, B is 35, so I substitute in and solve. 120 squared plus 35 squared equals C squared. And then I evaluate. So I have 120 squared is like 14,400. Okay, so I write that down underneath here. 14,400 plus 35 squared. So I'll write that into my calculator because it's scientific, plus 35 squared. Scientific means it does the Bedmas in the correct order for me, equals 15,625. Equals C squared. I forget what that number was. It was the square of 35. 35 squared equals, 1225. Okay, 1225. And then when I do this addition and I take the square root of it, 1440 plus 1225 equals, so I have, 14400. Oh man, I should just do this with the mouse pad. 14400, there we go, plus, geez, 1225. So this is that expression. I have this number. And then once I have this number, I take the square root of it, and it tells me that it's 125. The last thing that I do here, well, I'm going to write down C is equal to 125, because I found this gives me what C squared is, but when I take the square root, then I get C, okay, which is 125. And then I'm going to look over here. Does that look reasonable that this would be 125 long? This is 120 long, and that's 35 long. Those numbers are all in a range of reasonableness. If I started by making a guess, my guess would probably be a bit bigger than 120, but not a lot bigger than 120. And there we go. We get a number that matches that. If I get a number like 57,000, I have to be able to look at that diagram and say 57,000 is not reasonable. I should check my algebra. Now here, many people were able to give me the correct answer by setting this up as A squared plus B squared equals C squared. And then they know to put in 11 squared here for A, or for B, doesn't matter. And then to put in 15 squared for the other side. And then by subtracting 121 from both sides, they're able to get B squared, because 11 squared is 121. So I subtract that from both sides. 15 squared is 225 minus 121. And then you get b squared is equal to 104. And then we can very easily estimate that b must be between 10 and 11. Because 10 squared would be 100. 11 squared would be 121. So this looks to be like, oh, maybe about 10.2. Actually, it rounds to 10.2. So b is equal to 10.2, right? Done. I can move on. I can circle that final answer. No! These are meters. So this is not 10.2. It's 10.2 meters. That makes a difference. If you're a contractor or you're writing a diagram or you're giving instructions to someone, they need to know 10.2 what? It's not 10.2 pats on the back. It's 10.2 meters. So write in your units. Okay. So this one here. Now we get to calculating areas. And calculating areas is like where multiplication comes from, basically. Multiplication is calculate for me areas, calculate for me volumes. So this is really foundational stuff for math. This is like the birthplace of math type stuff. There were lots of different ways to divide this figure up. Some of you divided this into 3 rectangles and a triangle, like that, which is fine. And if you do the work correctly, you will get the correct answer. You would say 5 times 6, this one is 30. You would have to determine how tall this is. And you would say, well, if this was 6 and this was 10, then this must be 4 tall here. And this would be 5 times 4 is 20. And then this is 7 long. Ignore 15 down there. Some of you said this is 15 long. I'm sorry, but this is 15 here. This here is 7. So 7 times 4 would be 28. And then I need to figure out the dimensions of this triangle. Well, this is 4. And there's a few ways to figure out the other sides. This is given as 5. Because here, this is 5 inches and it has this mark. So that means this is 5. And then we have a 5, 4, 3 triangle. But you can determine it another way. If this total is 15, this is 5. We have 10 from here to here. This is 10. How do I know? Because 15 minus this 5 here would give me this 10. And then 7 minus 10, this would be 3. And so we notice that this is a diagram that works and creates a 3, 4, 5 triangle. You could also find that, this is 4 because we know that's 4, and this is a rectangle over there. And then this is given as 5, and so you use Pythagorean theorem to find that that's 3. 3 squared plus 4 squared is 5 squared. So what's the area of this triangle? Base times height, which is 3 times 4 divided by 2. 3 times 4 divided by 2 equals 6. So this is area 6, this is area 28, this is area 20, this is area 30. Add these together. 30 plus 20 is 50. 50 plus 28, 78. 78 plus 6, 84. So this is altogether 84 inches squared. 84 square inches is the correct answer. Okay. Now, you did not need to divide it into that many pieces. You can divide it into these 2 pieces, a large trapezoid and this smaller rectangle. And I'd encourage you to look for easier ways to do the work than harder ways to do the work. So in this case, this side is 15 inches long, and this side is 7 plus 5 is 12 inches long up there. And then the formula for area of a trapezoid, and then this one is 4 inches still tall. So then you would have 12 plus 15 divided by 2 multiplied by the height, which is 4. And this is working from your area of a trapezoid formula. And I should start by copying out the formula, to be honest. The formula is A plus B, which are the 2 parallel sides of the trapezoid, divided by 2, multiplied by the H. Okay? And then you'll see I've substituted into that formula, plus the area of the rectangle, which is length times width, which is 5 times 6. 5 multiplied by 6. And that's the area of this rectangle on top. Okay? So the area of the trapezoid plus length times width is the total area that we're looking for. So this is area, and you'll find if you do it that way, you'll get the same answer because both methods are correct. This one is better because it's less doing. You have to crunch 2 formulas instead of 4. This one here, also no way to do this without dividing it up. And the common error here was to double count this part of the circle. Okay, so you don't want to double count this area here. You want to call this area 1, referring to this whole rectangle, and this area 2, referring to this semicircle, half of the circle. So we have, what's the area of the rectangle? Well, it's the total area. The area of the total would be equal to the area of the semicircle plus the area of the rectangle. Okay? And so the total area is equal to pi r squared, but it's a half circle, so I divide it by 2, plus the area of the rectangle, which is length times width. Now, substituting into my formulas, I have here length times width, which is 7 times 16. Okay, that's my area of this rectangle here. That's number 1. And then number 2, wait, I need the radius of that circle because radius is part of my formula. So I better find the radius here. If this is 6 and this is 16, then this whole thing here is 10. If the diameter of the circle is 10, then the radius is half that. That's 5. So I need to use pi times 5 squared, all divided by 2. And so then I get 25 pi plus 7 times 16 is 112. Is that right? 112? I think so. 112. Okay. And then, yeah, it's 112. So now I evaluate and we get, what was it? Oh, 25 pi. Oh, sorry, over 2. 25 pi over 2 plus 112. And then the answer was what? 151 point something centimeters squared. Include the units. Centimeters squared means I took centimeters in the horizontal and multiplied by centimeters in the vertical to give me squares. That's your new unit, square centimeters. Okay? I think it was 151 or so. Now we consider the container below. What is its volume? What is its surface area? So here the mistake was thinking it's a cube. But it can't be a cube if its sides all have different lengths. So, yeah.
So Daniel booked Chromebook bin.
Can you unbook me for period 2?
Oh, okay, that's easy.
Thank you. Sorry, I forgot. Here, so these are all different dimensions. So it's a rectangular prism. It's not a cube. Can't be a cube with different dimensions. So the volume is equal to length times width times height, and then you substitute in. The surface area is equal to, well, it's 2 times this face, because this face happens on this side and the back side, 2 times this face, and 2 times this face. You're welcome. This face here happens on the top and bottom, and this face here happens on the left and right. This face happens on the front and back. So that's why it's 2 multiplied by length times width, that's, call it this face, plus width times height, plus height times length. You just have to make sure that you get all of them multiplied by all the other ones to find the surface area there. Substitute and solve. That question was done quite well with these numbers when people had the correct formulas. But you want to make sure that you write out your formula first. That really organizes your work and it helps you avoid errors. So here I'll just show you what it looks like. This would be 3.2 multiplied by 4.5 multiplied by 4.2. And then you evaluate and you are correct. Okay. Same thing over here. I just substitute in and solve. Now, the Pringles can. The Pringles can was an interesting question. Some people were able to really have some great thinking about this question, and others got stuck on a few common problems. First problem is read the question carefully. We need to find the volume of the tube, and we need to know the amount of cardboard needed to create it. And where do we need cardboard? Just for this part around here, not for the top and bottom. We don't need that cardboard. We don't need the cardboard at the bottom either. Those are made out of tin. They're not made out of cardboard. So one way to do this is to copy out the formulas and solve. The volume of a cylinder is equal to the area of the face multiplied by the height. The area of the face is pi r squared, and then the height is height, so it's pi r squared times h. Substitute and solve. What's the radius here? Well, this tells me the diameter is 7. And that was a common error to use 7 as the radius. The diameter is 3.5, half of 7. So I substitute in pi times 3.5 squared, and then I multiply by the height, which is 21 centimeters. Okay. Now this is a Bedmas problem. You must evaluate the exponent first before you multiply by pi, before you multiply 21. If you multiply one of those numbers in first, it goes along for the squaring ride, and your number will be way too big. And you will get a volume that's like above 808 centimeters cubed, which is correct, I believe. I think the answer was 808 centimeters cubed after you solve this correctly with Bedmas. And include the unit as well. You can also have a sentence there. Therefore, the volume is about 0.8 liters. Is one way you could have given me the answer. No one gave me the answer that way, but I can kind of visualize what a liter is, and a Pringles tube is a little bit less than a liter because 1 liter is 1,000 centimeters cubed. Okay, but what about the cardboard for the walls? Well, it helps to draw a net. And here is the shape that I would roll up into a cylinder. It's the same shape as your test paper and roughly the same dimensions. If I roll this into a tube, this could be a Pringles can, right? And so that could be the area that I need of cardboard to make this Pringles tube. This would be just the height of the Pringles tube, which is 21. And up here would be the circumference of the Pringles tube, which is equal to 2 times pi times the diameter. So I'll substitute into that. So that would be 2 times pi times 3.5, which is, I can't remember what, but it's a little bit bigger than 21 because the diameter is 7. So 2 times 3.5 is 7. 7 times pi would be a little bit bigger than 21 because pi is a little bit bigger than 3. So I have a number here that's a little bit bigger than 21 squared. So it's a little bit bigger than 441. So I think the answer was something like 450 or something like that. 450 or so centimeters squared is going to be your answer after you multiply this by this. And then you would say, therefore, you will need about 450 centimeters squared of cardboard. Now, I'm not working these out and evaluating them because, well, you don't need to see me crunch things on a calculator. If you crunch your numbers on a calculator and they're close to the numbers I'm giving you, then they're correct. Last, the ice cream cone question. This one, we want to know how much ice cream, and we would measure that not with length. We don't measure how long is the ice cream. We don't measure what's the area of the ice cream. We don't use ice cream like paint because we're not toddlers anymore. We don't finger paint with our ice cream. But we do measure it in volume. You can buy a certain number of liters of ice cream at the grocery store. You can say this ball of ice cream is roughly the size of a baseball, not roughly the size of a baseball diamond. We wouldn't use area. We would use volume. So we want an answer that's giving us the volume of this cone and the volume of this half sphere, a hemisphere or a semisphere. So we would say the volume of the total is equal to the volume of the semisphere plus the volume of the cone. Okay? And that will add together these two parts. And then we write out our formulas. Write out your formulas at this point. So you would say this is 4/3 pi times the radius cubed all divided by 2, plus, well, here the volume of a cone is the same as the volume of a cylinder divided by 3. So it's pi r squared, the volume of the face, multiplied by height, divided by 3. And then, if we did some algebra here, we'd find these two things are going to be the same. So this is equal to, I can just sub in and solve. We would say 4 over 3 pi times the radius cubed. The radius here is 4 centimeters. So that's 4/3 pi times 4 squared, all divided by 2. And then plus, this is pi times 4, oops, not the radius. We're going to substitute here, Mr. Jennings. 4 squared times 8, all divided by 3. And then if I'm really sharp here, I can notice 4 squared times 8 is the same thing as 4 squared times 4 cubed. My goodness, I had an error there. This is 4 cubed. 4 cubed times 4 divided by 2 is the same thing as 4 squared divided by 8, multiplied by 8. And then I have pi divided by 3 in both places, and those are the same thing. And that works out to be, someone has the correct answer here, it's 268, I think. Call it, if after you evaluate this, you find both of them are about 134. So it's about 134 plus 134. And it works out to be very close to 268 milliliters of ice cream. 268 centimeters cubed is the same thing as 268 milliliters. So about a quarter of a liter of ice cream in one ice cream cone. So it gives you an idea of what you're eating if you're eating a reasonably sized ice cream cone. It's about a quarter liter. All right. So then I might have a therefore statement here. Therefore, this is about a quarter liter. There is about 1/4 of a liter of ice cream. That's rounding to the nearest quarter liter. A quarter liter would be 0.25 of a liter, or 250 milliliters. This is 1,000 milliliters in a liter. Okay, so now for the bonus. We want to know about how quickly she eats her ice cream. If we know her speed, we know how far she walks. She walks a diagonal of a park that measures these on a side. We know her speed. We can use that to find out how long she walks for, and then what her consumption of ice cream is in terms of milliliters per second. So let's do that. You start with a diagram. Pion, 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 pion. It's 233 meters on this side, 377 meters on that side. And it doesn't matter which side is which, the answer is going to be the same. She walks diagonally across this. Oh, mon Dieu, it's a right-angled triangle. And so we're looking to solve for C here. So you have 233 squared plus 377 squared equals C squared. Start with a guess. I think going diagonally across that park should be more than 377 meters, but less than 610 meters. So probably like, 450. And then you work it out and you find that it's 443. Okay, C is equal to 443, I think, meters there. So that's how far she walks. And then you have to figure out how long does it take her if she walks at 1.65 meters per second. And there's a few ways to figure out what I need to do with the number, how far she walks and how fast she walks, to get it to output for me how long she walks. The first way to answer this is to think of an easier question and then answer that question. If someone goes 100 kilometers and they're traveling at 10 kilometers an hour, it should take them about 10 hours to do that. And then I can imagine the 100 must have been on top, the 10 must have been on the bottom, and I used division to get 10 hours. I can kind of intuitively understand that.
1 minute warning to turn
and then I can use the same
projectors
thinking
in
and the same
for our extra long broadcast this morning of CCI AM.
And I can use the same thinking to undo what these numbers are doing and get
Please
that.
excuse the interruption. If you drive a gray Honda with license plate CMBS384, your
Still
lights are
recording.
on.
Okay. The other way to do it is to say, okay, she walks faster than 1 meter a second, but slower than 2 meters a second. I'm expecting this number here to be a little bit less than cut in half, so I must use division. So then I take 443 and divide it by her speed, 1.65, and that will give me how many seconds it takes her, which is 268 or thereabouts, 268 seconds. And then I notice it takes her as many seconds to walk as she has milliliters of ice cream. So she consumes 1 milliliter of ice cream per second. Dun, 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 dun. That's the answer. 1 milliliter of ice cream per second, everyone. That's a very fast way to finish an ice cream cone. So any questions about that, absolutely hit me up by email or come chat with me at lunch. Otherwise, I hope the rest of your math practice today is fruitful, everyone. Bye for now.